Hang on. Going live to Facebook.
A very good morning, attendees. Welcome to the Osteoporosis and Fall Prevention Festival organized by StataCom Health. My name is Huda and I'm your MC for today. Mr. Chris Hughes is a COO and a principal owner of Foot Mind and Foot Scientific in Draper, Utah since 2011. He developed 4 feet and ankle products in conjunction with foot and ankle surgeon and physical therapies. He also moved products from concept through manufacturing to markets. Please take note that you're only able to ask questions during the Q&A session at the end of the talk, either through the Q&A box, chat box, or you can raise your hand and we will unmute you. Now I'll pass the time to Mr. Chris.
Thank you, Huda, and thanks to Esther too for organizing this for me at any rate with StataCom Health. Also grateful for Jessica at Zhao. She's the CEO and she's our distributor in Asia, and just really has an eye for picking really the finest quality products. So I'm really grateful that she was willing to take us on, and I think for good reasons, I'm hoping. But I'm interested in this topic and have been for quite a long time of falling, particularly as it relates to drop foot, which is sometimes called foot drop. And the problem has been traditionally, at least until about 10 years ago, when we entered the market. Now there's a lot more braces on the market in the last 10 years, a lot of variety. But when we entered the market, particularly, there just really wasn't very many good solutions, and there's still not a lot of really good solutions. And the problem is that people know that they should wear the brace to avoid falling, but they tend to not because they're usually difficult to put on. They're uncomfortable, they're unfashionable, and various reasons like that. And so we're going to talk about some of the issues of falling as it pertains to drop foot today. And I'm going to just, so you don't have to keep looking at me, I'm going to just share my screen and we can get a kind of walk through a PowerPoint on falling and drop foot. And I hope that will be useful for you folks. So this is us, Foot Scientific. I hope you can see my screen. Is that working? I'm hoping it does. And my cursor. This is Zhao, who we distribute through. This is us. And let's see. This is where, let me pause this really quick. Let's see. I'm going to rewind this one. Drop foot is essentially where a person can't dorsiflex. In other words, they can't lift their toe upwards. And so we automatically do that in our gait cycle so that we clear obstacles in the path, and so that we can have a smooth walk. We automatically, unconsciously, we lift our foot, or we consciously lift our foot. But either way, we do so typically, well, we can do so, we can lift our foot because of the perennial nerve. And so we're going to talk a little bit about the perennial nerve because it's so important, and this will help you as clinicians and researchers, et cetera, to understand how you can help patients to avoid worsening their drop foot or avoiding drop foot altogether. The perennial nerve is this nerve that comes from the spinal column down through the back of the knee. This is the kneecap here, down through the back of the knee, and then it crosses over at the fibula. And so there's a lot of exposure to this nerve right here, and it's vulnerable to compromise and to damage. So let's just talk about some of the ways that this typically happens. And it's really hard to really know what is more prevalent or I've tried to do the research on percentages that come from injury or from general neurological disorders or other issues, and it's hard to know, but I can give you maybe some ideas. So the perennial nerve can get damaged, and then the foot can't lift because this signals the foot to lift, the muscles of the foot to lift, because of injury, to the spine or to the knee, fairly common. A lot of times this happens through like a motorcycle accident, but a lot of times it will happen through surgery. You know, the surgeon nicked the perennial nerve. And so they come out of surgery. Now they can't lift their foot. They don't know why. A lot of times this can be damaged through a fracture to the fibula. Breaking the fibula, of course, would stretch or compromise or even break the perennial nerve, sever it. But another reason we ought to be aware of is that long-term constriction in this area, like a tight plaster cast, for example, can over time compromise or deaden the perennial nerve. But other regular pressures also can cause the same problem. For example, too much of crossing the knee or sleep positions, particularly in cases of neuropathy, where the diabetic person with neuropathy can't feel, they're not getting good sensory connection, so they can't feel their perennial nerve. And then, of course, just general deterioration from, for example, multiple sclerosis, Charcot-Marie-Tooth syndrome, and other neurological problems where, for example, the myelin sheath on the nerve is compromised or slowly deteriorating, and it loses its impulses. I mentioned Charcot-Marie-Tooth syndrome specifically because it affects more of the peripheral nerves that, for example, the ones affecting the foot and in the lower leg, like the perennial nerve. So that's kind of where it comes from. I'm going to go back to this slide, and this is kind of what we look for in the patient's gait. They'll tend to swing their foot outward in order to avoid. Whoops, sorry about that. They'll swing their foot outward in order to avoid tripping when they're not wearing their brace. So if you see somebody walking like this and their foot's kind of falling, they're just basically trying to avoid, tripping on something that might come up. And it's amazing how closely our foot can come to little obstacles and fall and trip. And so relative to how to address drop foot, we're going to talk about bracing. Mostly bracing comes in if the perennial nerve is so compromised or it's severed that a person can't lift their foot, obviously. But what we want to try to remember is to try to keep this dynamic on number 2 here, this dynamic between stability. So the brace needs to have stability, keep the foot stable, but also muscle retention. There's 100 muscles, tendons, and ligaments in the foot. And to get credit for this class, you have to memorize all of these by the time I move this slide. So that's going to be tough. Just kidding. But what we do need to know is that we want to keep these muscles and tendons strong. We don't want them to be compromised. And if the brace is too stiff, for example, we're going to start to have weakening of the muscles. There's going to be atrophy. So let's talk about different kinds of bracing that's useful to help the patient keep their foot off the ground and not trip and fall. This one is a Bioness. It's a nerve stimulation. You'll see there's no braces around the foot and the ankle. So the foot and the ankle does retain muscle mass. The Bioness or other nerve stimulation devices, they use complex muscle movements to trigger the lifting of the foot. And so they're not for everybody, because sometimes everybody has a little bit of a different biomechanics, and if this works, that's great. It stimulates the perennial nerve to lift the foot, and that's the way it works. The problems with the nerve stimulation braces that are out there are that they are very expensive. and they're helpful for a very narrow range of patients, one that the nerve stimulation works for because of the muscle movement complexity, and also a nerve that isn't completely damaged, because there still has to be a signal that gets all the way down to the foot. So it has to be in that kind of middle area where a brace is needed, but it's not, but the nerve isn't severed. So that's the bionerve. It's very expensive, into the thousands of dollars. This is the traditional AFO. And this is what's been around forever. And people still, this is the go-to brace. This is what most people are familiar with, mostly because they don't know of a lot of other options. And this is, and also because, well, orthotists, for example, make money on making these and customizing them, and they are often paid for by Medicaid, et cetera. And so you'll see a lot of these, even though this is why we came into bracing, is because they're so typically uncomfortable. Now, in this particular one, it's coming off the side into the shoe, and then it holds the foot stable. They usually come off the back. But this is one that comes out into the shoe off the side, around the lower leg and around the calf. And then it holds the foot up in a stable position. And it does a good job keeping the foot stable and lifted. It's just the problem is they are hard against the foot over time, and they're almost always quite uncomfortable, and they require a larger shoe size or a specific, often unfashionable shoe. And they're also quite expensive, not like the nerve stim, but into the several hundreds as opposed to the thousands of dollars. And the concern that I have with them from a clinical perspective is both the compliance, because people just don't want to wear them, but also because they hold the foot in such a rigid position that the muscles around the foot and ankle can start to weaken. When they're not wearing the brace, they're more vulnerable then to falling. So those are just some issues to be aware of. Even though these are, you know, and they're getting better and better. Here is a third alternative that came around about 10 years ago when I started doing our brace, which is these out of the shoe orthoses. They surround the leg just above the ankle, or just at or above the ankle. They reach into the shoe via different methods, and there's lots of different kinds of out of the shoe braces that use different methods. They do maintain good muscle tone and avoid atrophy around the foot and the ankle, but typically they're very cheaply made, unreliable, and difficult to use. So if you have, for example, if you're paying less than $80, you're going to get a brace. This is a brace that's the most popular in terms of sales, out of the shoe brace. But again, it's under $80, and they're very they're just kind of really flimsy. They don't do a super good job with that kind of stability that people like, and they fall apart really quickly. And so that was kind of a problem that where we came into the market as Foot Scientific, to try to help the patient have a sturdy brace that's stable. And this is just a part of it. We'll get into more of this, but that also is it's stable, but it's also out of the shoe, so that there's going to be the stabilizing muscles can continue to stay strong around the foot and the ankle. And it's also a lot more comfortable. And these out of the shoe braces, all of them are more fashionable, you know, in terms of the shoes that can be worn, et cetera. This is an example of a tennis shoe, but they can be worn with a variety of shoes. So we did a lot of research before starting, just in terms of what problems people have with the bracing that was out there. And there's usually, it comes down to three essential, you know, problems that keep people from wearing the braces they had. And that is, from our surveys, the comfort, style, and function. I should say that that's the research that drove this brace. However, some people with drop foot, they want a solution, and they don't want to wear something uncomfortable. So Dr. Fox, who I'm a colleague with, was finding a lot of people coming into his office that were wearing braces that were just like that they made from home, that were basically cuffs around the ankle, and then they would use like zip ties and rubber bands and all kinds of things to try to tie it to their shoe and make this work. And so this isn't like unique. The people with drop foot knew that maybe this is a solution. We just had some of the tools to make a solution that really works well. So comfort is one of the issues. People wanted something out of the shoe, something sturdy but comfortable in terms of the material, and something that equalizes the pressure around the ankle so there's not too much pressure in one particular place. The style was important. This can be used with any number of shoes, including sandals, even dress shoes. We do have a hole puncher, but any kind of bootery or some kind of shoe cobbler can put a hole in the shoe. But we also sell these little punches that are useful, but they're not needed. If you have a tennis shoe, like here, you can just put it right into the eyelets. And typically you could just put our hooks right in the eyelets. But the variety is nice, and that's helpful to people. And then thirdly, the function. Just going to show this for a second. It's easy to put on. The lift can be customized. That's important to people because it can be lifted to the angle that's the best angle. And then there can be a quick release of tension, and it's really the easiest brace to use when there's fine motor skill problems, because it doesn't take a lot of complex kind of putting on once it's put on. I mean, once you have it configured in the shoe, putting the little eyelets, the eyelet anchors in the shoe is a challenge the first time, but once they're in, they're in. And then it's both stable and flexible so that muscle mass is retained. I'm going to go through this again really quick, just to show how this works. Maybe we can pause it. So the Velcro holds it nice and snug, and that's helpful. And then it snaps on once you've adjusted the strap the first time. You don't have to do it again. It just snaps in. And then the important part I wanted to just kind of show here is that this angle can be adjusted. And that's important because a lot of people have spasticity in the foot. And so their foot is kind of like really rigidly in an everted or an inverted position. And they need to kind of stretch the foot over time. And so I'll talk about that in a little bit, that kind of stretch that's important. But I just want to show you kind of like, again, this was the kind of the idea without the Elevate 360. This takes, we put the Elevate on this person, and they didn't immediately start to walk straight because they were still scared. But after only about 45 minutes to an hour, we could get a really smooth, straight gait with this. You can't see the bracelets, but it's hooked to the shoe here. Let's see if we can at least show you that there's the kind of hooks right there. Yeah, it takes a little time to gain confidence, but not too much time before they're starting to walk with a normal gait. And people are just so excited, you know, it just says this is like changing their life. Some of them are moving to being able to get back to their getting back to some of their hiking and running, and doing some things that were very hard and difficult with the rigid brace. So we're excited about this relative to falling, obviously. But I just wanted to talk about something that is also an issue with falling, and that has to do with inversion and eversion. And I just mentioned that briefly before. But inversion is where, well, I'll just show this video. It's just the easiest.
Many people experiencing drop foot also experience inversion or eversion. Inversion is where the front of the foot pulls inward or medially. Eversion is where the front of the foot pulls outward or laterally. Both of these shoes are right shoes. To correct for eversion, using this brown shoe, we place both anchors on the inside or medial aspect of the shoe, whether it's a left or a right shoe. To correct for inversion on this gray shoe, we place both anchors on the outside or lateral aspect of the shoe. On most tennis shoes, the eyelets run low enough to place the anchors in sequence on the bottom two eyelets. On this example of a left tennis shoe, the black anchors represent where the anchors are placed to correct for eversion, again on the inside, whether a left or a right shoe, and the silver anchors represent where the anchors are placed to correct for inversion. Regarding where you put the anchors, they can be anywhere on the shoe that lifts your foot in the direction you desire. You may want to use an old shoe to experiment with anchor placement, as well as how and where you place the lace. In the end, you'll have a brace that brings the inverted foot into a more neutral position where the lateral part of the foot lifts and is pulled outward, and where the everted foot is placed into a more neutral position where the medial aspect of the foot lifts and is pulled inward.
All right, and then another issue that's helpful. So the issue is that if I were to just go back on this really quick, is the issue that I'm trying to explain here is that you can stretch this incrementally. The foot, the tight muscles that are causing eversion or inversion can be stretched so that one day you might get a little bit of stretch, and the next day you get a little bit more stretch, and pretty soon you have a much more flexible foot around the ankle. So it's not so pulled in such a tight, uncomfortable position for the patient, and they're not tripping as easily. Another issue, and I don't know if we have time for this one, is plantar fasciitis. I'm going to skip that, but basically the plantar fascia, you know, is the bottom ligament of the foot, and it can get some micro tears at the heel, which can be by stretching the plantar fascia, it can cause those to heal quicker. And so some kind of stretching every day is helpful, but this can also help stretch the foot for plantar fascia. Now we just barely got our first shipment of the Elevate for Child. And instead of using those anchors that you saw that were in the shoe that you put for the adults, which are needed, we just simply use these hooks that go into the children's tennis shoe, which is very helpful and easy, and they don't come out, which has been super helpful. So it's just a smaller, it goes down to the tiniest of ankles, just the tiniest of ankles, which is very helpful. And this is an example of a boy who's just for the first, second, third time, just trying to use these. His mother was just thrilled that we came out with these. This is one of the first trials. We have lots of parents who are so excited now. For the past 5 years, this is from the mother. Peter, for the past 5 years, he's tried all kinds of braces. They've been too bulky and heavy, so he hasn't had the benefit of the bracing while walking. He was happy with the product because it supports Peter's needs without all the bulk and weight, and provides the stretch. And it's back to that stretch, because you can incrementally stretch the foot. A lot of children with the issues that they have do have eversion and inversion, and they need a stretch. And there's not another brace that really provides that, especially from a center point. There's another brace that's out now that kind of comes from outside of the brace, but if you want a good pull left or right on the foot, you need to kind of come from the middle. And so anyway, it helps him keep the needed range of motion, and he can wear his regular shoes. That makes him excited. So he'll get better and better at walking, and even perhaps be able to, or hopeful, not be so dependent on those crutches. So I don't know, I'm getting close to where the time is out, but I just wanted to cover one other issue about falling that we try to address, and I'll just try to do it briefly. And that is falling and the supinated foot. The supinated foot is a foot that has an angle like this. Instead of being straight down to the heel from the tibia, it has a bend that is kind of rigid, and the arch is very, very high. If you took a footprint, you'd see very little of their foot around the arch. And because of this, their ankle tends to roll outward. And the shoes tend to wear quickly on the outside or the lateral portion of the shoe. So those are some things to watch for. You'll see somebody, just as you can notice somebody with a flat foot, they're pronated. The supinated, and we have an orthotic for the pronated foot, but the supinated foot is a high rigid arch. And the subtalar joint, which we can get into if there's a second, is locked. And the subtalar joint's really responsible for a lot of the flexibility of the foot. Now, there's two things we do to unlock that. And surgeons who know, who are expert at this, really saw our orthotic and they went crazy, because there's two things that cause an unlocking of that subtalar joint. So it neutralizes the foot. One is that you get this wedge. We need to put a wedge here to neutralize the foot against the ground at the heel. That's one problem with the supinated foot, is that it's rolling outward. We correct for that with our type 3. The other thing we do is we drop the first metatarsal, the big toe ball, the ball of the big toe. We drop it into a pocket. Now, between doing this and the wedge, it unlocks that subtalar joint. There's a lot more flexibility, and it has a neutral landing on the ground. Some of the larger muscle groups are able to be utilized. It's not putting so much pressure on all the small, tiny ligaments and tendons in the foot. It also, by the way, neutralizes the foot laterally, so it takes pressure off the inner knee for those suffering from knee arthritis. So that's basically our type 3 foot, and our type 3 orthotic. We also have a type 2 that neutralizes, that's just kind of a good cradle for people, has a lot good cushion, and then a type 1 that neutralizes the pronated foot by putting a medial wedge as opposed to a lateral wedge for the supinated foot. So that's Foot Scientific's my presentation for this. I'm going to stop screen sharing. Again, very grateful for Zhao and Jessica, who's an amazing person, and who one of the very few people I've seen who's truly interested in just simply finding the very best of the best that are out there. But I don't know what else to say. Let me see if there's some. Okay. Here's some questions that I will cover the best I can. When I say expensive, typically and this can be Googled, but like a BioNess brace is costs, or any kind of nerve stimulation brace, they can be to $3,000 to $5,000 for a nerve stimulation brace. That's the one I showed you where it stimulates the nerve from the knee or from the lower back. I mean, from the knee or the upper thigh. So that's about 3 to 5 for the nerve stimulation. For the typical AFO that we talked about that goes in the shoe, those range anywhere from about 200 to about 500, maybe even down to 150 to $500. Sorry, this is US dollars. So I'm talking in US dollars, but about 150 to 500. Sometimes it takes sometimes they need some adjustments, etc., that cost a little bit of money too, and they have to be adjusted to the foot. And we currently don't have anything to treat bunions, but we'd like to. But thank you for asking that question. I saw that from Esther. We have some ideas. But okay, so that's about all I have on falling and drop foot, and I'm hopeful that's something useful. I did put my Dropbox link there, and I also am going to send this to SATA, the Com Health, in case my Dropbox folder isn't something you can use, and I guess that's the conclusion. So thank you. Guess I could have taken more time on each slide. Huda?
Hello.
I'm going to leave now unless there's any more questions.
If there's, oops. All right, so if there's no more questions, I would like to thank you, Mr. Chris, for sharing. It was a very beneficial one. And thank you, attendees, for attending. We hope that you have benefited from the sharing earlier today. If you have any inquiries, feel free to email us at mediacontact@sata.com.sg, or you can contact our hotline at 6844-6688. I repeat, 6844-6688. Till then, take care and goodbye.
Thank you. Goodbye. I'm going to answer a question really quick here. Do braces have to be worn for life? I'm going to, it depends on the severity. Some nerves come back. Sometimes the perennial nerve comes back. But usually, yeah, a drop foot patient is a drop foot patient most often for life. So I think that's the last question. So thank you. I'll type in the answer to that.
Thank you everyone once again for joining this webinar.